Hello Legacy students, Marsh here. So today we're going to look at focus and directrix parabola story problems today. Basically taking what we know about a focus directrix form and then expanding to that into the real world context. So, surprisingly enough, a lot of things in the world actually have parabolic, or they're parabolic in nature. A lot of times they look or have something that looks like a parabola, or they have a bowl showing. One kind of those would be a flashlight. So on this I have a searchlight has a parabolic reflector. Basically it's a cross section that forms a bowl. The parabolic bowl is 16 inches wide from rim to rim and 12 inches deep. The filament of the light bulb is located at the focus. So now you know why we're kind of looking at that today, because we're looking at a focus and directrix form. So I need to know the equation of the parabola used for the reflector. So if I would draw here my graph, and it doesn't say we can't put at 0, 0 for a center. So we're going to put 0, 0 here for our center. And I need to draw a parabola here, so something like that. Now, they told me that the parabolic bowl is 16 inches wide from rim to rim. So that would mean from here to here, if this is my flashlight, this would have to be 16 inches, right? Which tells me, since it's a focal width would be 16, that tells me that each half would be 8 inches, right? And then it says 12 inches deep, so that would mean from like the end of the flashlight to where it meets the handle would be 12 inches right there. So if I would be considering this to be a graph, I would consider this right here to be the dot 8 comma 12, right? Because it's 8 over 12 up. Now, why do I need a point? Well, ultimately I'm trying to find P, right? I don't know what P is in our equation. But if I have an ordered pair for my x and y, I can find P easily. So I know it's an upwards facing parabola, so we're going to have x squared equals 4py. My x is 8, so I can plug that in. Don't know P, right? Because we don't know where is the focus located. That's kind of part of the part we need to find. But I do know y is 12. So I know 64 equals 4 times 12, that's 48p. So if we divide by 48 on both sides, I get 1.33 equals my p. So my equation of the parabola will be x squared equals 4 times 1.33, which is approximately 5.32 y. So that would be the equation, because 4 times 1.33 is the 5.32. How far from the vertex is the filament of the light bulb? Well, that tells me that they want to know what's the distance between the vertex and my focus. Well, that's just our p-value, right? Yeah, so how far is the well, it's 1.33 inches away from one another for B. So all this is sometimes, guys, is just knowing what are they asking, what do they want, what don't they want, that kind of information. So this next problem, the cables of a middle part of a suspension bridge. Now if you've never seen a suspension bridge, what is that? Basically it's one of these kind of bridges where they have the poles in the middle. Golden Gate Bridge is a suspension bridge. In the form of a parabola. So notice as I drive, there's a parabola right here. And the towers supporting the cables, these guys, are 600 feet apart and 100 feet high. So what is the height of the cable at a point of 150 feet from the center of the bridge? That tells me that we need to know some more information, right? We need to have the equation for this. So let's go ahead and draw here our graph. Doesn't tell me I can't put it at 0, 0, so the bottom of my bridge is going to be at 0, 0. Got a parabola here. There we go. Well, this would be where my towers would be, right? This would be a tower here, tower there. We know that this is 600 feet apart. So right here to right here, that is 600 feet, which tells me each piece is 300, right? Because our focal width would be 600, which tells me I'm 300 both ways. And I'm 100 feet high, so that'd be 100 right here. So this dot, this endpoint right here in my parabola, would be the point 300, 100. I'm 300 this way and 100 up there. So what is the height of the cable? I need the equation of my parabola. Since it's an upwards guy, so it's going to be x squared equals 4py. X is 300, so I got 300 squared equals 4, don't know p because I don't know the focus, times my y value, which is 100. Because they didn't tell us anything about a focus in the middle right here, so that I don't have my p value. 300 squared is 9 with 4 zeros, so 90,000. 400p, looks like I gotta divide by 400 to get p. I get 225 equals p. So my equation of my parabola that we're looking at is x squared equals 4 times 225, which is 900, y. Now, this is good. This is good to have the equation, because now they want to know at 150 feet from the center, so like right here, how far up is the cable from the ground. So what I can do is plug in 150 for my x. I need to know my y. So I can go 150 squared equals 900y. 150 squared, that's 22,500. Divide by 900, because we need to solve for y. And you know how high it is. I get y is 25 feet off the ground. So at 150 feet from the center, right here, I am 150 feet off the ground. Alright, let's take a look at the last problem for tonight. The parabolic antenna used by a television station is transmitted. That should be transmit. No E in that. Is 146 inches in diameter. Its focus is 48 inches from the vertex. So, if you guys have never seen a satellite dish, that's pretty much what we're talking about, satellite dish. What happens is any information that comes at the satellite dish, what it does is it comes, hits the bowl, and then that bowl, since it is a parabola, hits and sends to the focus. So no matter where the sign comes through, it goes through the focus. The focus is like the kind of like the sticking out part of them. If you've looked at a satellite dish, this allows you to collect all the receiving information. So let's go ahead and do some drawing here. So I got a parabola. They tell me it's 146 inches in diameter, which tells me that this is 146 inches across. So that tells me I'm 73 inches both sides. Focal width being 146, 73. It tells me the focus, so the thing that's sticking out, is 48 inches from the vertex. So if this is my vertex at 0, 0, right here is my focus at 0, 48. Write the equation of the antenna's cross-section. Assume it is pointing upward. So that's what we did. Well, it would be x squared equals 4py, right? I don't know anything. I don't know how high off the ground it is, right? I don't know the deep. That's actually what we're going to find. But p is just the distance from the vertex to the focus, or the vertex to the directrix. Well, I know how far the focus is from the vertex. It's 48 inches away. So I can plug that in directly to get my equation. So x squared equals 192y. Now, they want to know how deep is the antenna's dish, which tells me They want to know right here, this dot here at 73 for my x, what is the y value? How high is this dish on the ends? So I'm going to plug in 73 for x. Equals 192y. 73 squared is 5329. My equation told me that. Divide by 192. Or my calculator, excuse me. Whoopsies. 192. So I get y is 27.76, and we're going to assume inches. So when I go 73 inches from the center of my dish, I am 27 inches off the ground. So not totally long, about 2 1/4 rulers off the ground, if you want to consider it that way. Not too deep, but still pretty deep and satellite dish. And that's the end of this video. See you later, Sabers.